In our previous example, we actually got the same answer three different ways. We got 16 thirds. Now, two of the ways were an integral with respect to x and an integral with respect to y. The way in the middle was just two integrals with respect to y that turned out to be the same integral, the same as the single integral with respect to y. And this is a general principle. It turned out in that previous example that we could actually find the same answer two different ways. But a lot of times, only one way will work. So, this is continuing 6.1, and it's the area between curves, and there are two types of area. The types are called in the book type 1 and type 2, Roman numeral 1 and Roman numeral 2. You can think of them as the dx type and the dy type, and it's in alphabetical order. Roman numeral 1 is the dx type, Roman numeral 2 is the dy type. So, the dx type of area is the familiar one. You can find the area between a curve f of x and a curve g of x by taking the integral, and between endpoint a and b, those are given as well. The integral from a to b of f of x minus g of x. It's thought of by slicing up that area into vertical strips, and here's the important thing: the vertical strip there, which has a thickness of dx, is always touching one of the curves at the base, at the bottom of it, the g, and touching another of the curves, the f, at the top. So every vertical strip has the same top and the same bottom. That's the key feature of type 1. If they all have the same curve on top, f of x, and the same curve on bottom, g of x, then it's a type 1, and you can find the area like that, f of x minus g of x dx. So, compare type 2. Now, the two curves may not, they might not pass the vertical line test. Instead, they'll pass a horizontal line test. X is equal to g of y. These are two curves where we've solved for x. And x is equal to f of y. So every horizontal strip, every horizontal slice of this area has the same left-hand piece, which is the g, and the same right-hand piece, which is f. And now, that means it's a type 2, and the thickness of the horizontal slice will be dy. And the key feature is that every horizontal slice has the same curve on the left and the right. And then one little thing that is a key difference is that it's a little harder to remember that the larger number is on the right. It's just that the fact that the x-axis gets larger as you go from left to right. So f is in this picture, the curve on the right, and it's the bigger function. So we do f minus g, starting with the one on the right and subtracting the one on the left. The other difference is that now we're interested in a top and a bottom y value. C and D here are values on the y-axis. Just like A and B on type 1, you have to go from smaller at the bottom of the integral symbol to larger number at the top of the integral symbol. So C is a smaller number, D is a larger number. And next we'll do a couple of examples to see how these are set up. So, first example is to find the area enclosed between y equals x plus 4 and y equals x squared minus 2x for x greater than 0. Just to interpret that problem, you should know that when it says enclosed between, it's letting you know that there will be some extra steps, because it did not have to tell me where the start and stop are. It did tell me the start. It said start at x equal to 0. It says for x greater than 0, but that means it starts at x equal to 0 and goes to the right to x greater than 0. So from the picture you can see that I've discovered that there is an intersection of the two curves that we'll have to find. That's the question mark. So you can try it yourself, but now we're going to try to do it. We'll do it step by step.